All right, so start me through 7. We already started a little bit. Miles, how do you feel about giving me just a start to it for 7?
For 7, y equals a times by 1.12.
Okay, so there's our growth rate, and we're trying to find out how long it takes to double, but the problem is we don't know what double is. So, Tom, thoughts or ideas, do you remember from yesterday, or did you do something today to try to start problem? If not, it's okay.
Yeah.
No? All right, Max?
No.
Definitely not? All right, I feel pretty confident because I heard you telling Michelle. So, what was your thought or idea?
You can just pick any two numbers and just make sure they double each other.
Okay, so your choice?
I picked 150.
All right, so 100 is double of 50. So if we want to find how long it's going to take to double, just pick 100 and pick 50, or pick 2 and pick 1, or pick 200 and 100, or I think someone said 2A and A. Was that Evan or Sam? Sam said 2A and A. It doesn't matter because the first step we're going to do, Travis, divide by 50, so I'm going to 2 equals 1.12 to the x. All right. You could graph it. And graphing's a totally fine method. However, especially with this chapter, we're going to focus more on the algebraic methods. Okay, so Monty reminds you that if you want, you could just graph both sides, calc intersect, and you'll get a decimal answer, not a problem. I'm going to take, what do I need to do to solve this algebraically? Evan?
Take ln to xln 1.12.
All right. And actually, Evan said, look, he already knew that you're going to bring the x out in the front. And I love it. Evan knew, like, he's making me happy. He knew he could have taken log base 10, but he knew that I'm a fan of natural logs. So x is equal to the natural log of 2 divided by the natural log of 1.12. And what do you get about? 6.116. Monty, about the same thing on your calculator? Good. I like it. So far, so good? Tom? So, here's the thing. Whenever you're solving a problem, seriously, I don't want to move your seats, but I think that's what we're looking at next time. So, Tom, it doesn't matter if you take the natural log or log base 10 of both sides. If you do the natural log of 2 and log base 10 of 2, those are two totally different answers, but the ratio here is going to be the same. So if I do log of 2 over log of 1.12, it's true. The two numerators are different and the two denominators are different, but the ratio is the same, and you will get 6.116 here. Now, there are times when, like, you're using base E, and it would make perfect sense to use the natural log. You could do log base 10, and it would still work out, but it's like, it's an extra step. So, ln of E is 1, exactly. Okay? All right, so that was a nice observation that sort of Tom called to the forefront, like, is there a difference, and when would you use one over the other? And the real answer is it doesn't matter, but there are some times where it will be easier to use one over the other. All right, let's set up 8. Corinne, do you want to take a shot at starting us with 8? If the answer is no, that's okay.
No way.
Y equals a times 0.88.
Perfect. Okay, so Corinne sets up a perfect exponential decay with 0.88 as our base, and I want to find its half-life. All right, now, there are a couple ways of doing this. In this particular problem, it's sort of, we have a method that we just used that we could use a very similar method. Elizabeth?
Just take two numbers that are, one has to be half of the other.
Okay, and which should I put in where?
Put the half number in for Y and put the bigger number in for A.
So what do you want to pick? It's your problem.
I picked 100.
Okay, so 100 equals 200 times 0.88 to the x. And it doesn't matter whatever you pick, because the first step, what are you going to do, Travis? divide. And no matter which numbers you pick, you're going to get 1/2. Okay? Are you all right solving that? Okay. There's actually one that I'd like to take a look at from the homework tonight, just getting it set up. I think almost all of them tonight, or most of them, are word problems. And yeah. And number 51 says that a body of a man was found in melting snow in the Alps in northern Italy, and an examination of the tissue revealed that 46% of the carbon-14 present in the body at the time of his death has decayed. So have you heard of carbon dating?
Yeah.
Carbon dating is a method of finding out how old an organic material was. It has to have started off as an organic material like a body or a tree or something that was living, and when it dies, its carbon decays at a rate. And the carbon, in this case, they tell us, the carbon 14 has a half-life of 5,728 years. So carbon 14 stays around for a while, huh? Right? After over 5,000 years, you still have half of it left. And we want to know how long ago did the man die. So in other words, say again? So the person, we found the person in 1991 with 46% of the carbon 14, right? One would imagine that if we have about 46%, that maybe the person died about 5,700 years ago. Does that make sense? As a matter of fact, just conceptually, did this person die more than 5,728 years ago or less than 5,728? How much is left? More than half or less than half? Less than half, so he must have died more than 5,728 years ago. But the problem here is we don't have how do we set this up as an exponential equation? All right, well, what's an exponential equation? Peter, what's an exponential equation? All right, so y equals ab to the x. I don't really, what are they telling me? What information do I know? Well, they give me a percent, but I don't know, I don't know anything else. I don't know what B is. I don't know what A is.
A is 1991 plus 5,000.
What's A represent? A represents what? Initial. How much did you start off with? Started off with 100%. Okay? So you started off with 100%. Now, right now, the only piece of information that's really helpful is that the half-life is 5,728 years. So in other words, if I wait 5,728 years, how much will I have left? Try again. Half. 50%. If I solve this, what can I solve for? B. I don't have B yet. So I can't solve the problem until I have B. I could not. Oh, no. Sorry, no. I'm saying I can't solve this problem yet until I find B. So, no, you're absolutely right. I can totally... Yes, we can find B. And as a matter of fact, we need to take the 5,728th root of 0.5, and B is going to be about 0.9999. No, tell me. Wait, how many nines?
3 nines and
8789. 8789. And it is really, really, really important. You can't round this to 0.999. You have to store this. You absolutely have to store it. There's a store button. So once you have the number, you hit the store button, which is on the left-hand side. And then you store it, and then you go stow, right? And then the alpha lock comes up and you look at one of the green letters. Okay, and then you hit enter and then it's stored. And whenever you hit E now, that number's going to come up. Yeah. All right. Now I have an equation. Y equals 100 times 0.9998789 to the t. What do I want to find? T when? Yeah, so when I have 46%, how many years later is that? Okay, do you see how you can do that now? Are you glad that we started that at least? Actually, can I ask? It might not happen today, and I might have to ask tomorrow. But in chemistry, did you actually have an equation that was like a times 1/2 to the like h over t? Did you have an equation like that? Yeah. Sam says yes. Danny says yes. So there's actually another way of setting this equation up to solve it sort of chemistry way. And maybe if we have time tomorrow or on Monday, we can talk about the difference between how we set it up in pre-calc and how you set it up in bio or chemistry. But for now, the important thing to notice is before you could do anything, you had to solve for B. And it was because we knew that the half-life was 5,728. Okay, no one's listening now. All right.